All right. Good morning, everyone, and welcome. This is CSE2307, Programming Tools and Techniques. I am Professor Cook. I know some things in the crowd are familiar. They've already probably had me for Intro to Computer Science, either as a student or a TA, if we've met before. But hello. Just a little bit about myself. I've actually been here watching for 15 years now. I do mostly teach the intro class. The other main class that I teach, not the only class that I teach. However, I do have a soft spot in my heart for this class. I created this class a few years ago to fill some gaps that I saw, in the CS curriculum here, which I'll talk about more in just a little bit. Outside of class, I'm a big gamer, play tons of video games, so I'd love to chat to you about that. I'm also a drummer percussionist. I'm actually a member of the St. Louis Symphony Orchestra, which I'm pretty proud of. So I would love to chat to you about music sometime, if that's your thing. And I'm also a dad, so if you talk to me long enough, I'm definitely going to bring up my kids. They occupy a huge part of my brain. But we're here to talk about programming. We're here to talk specifically about programming tools and techniques. And the reason why I created this class, it's been about 5 or 6 years ago now that I've taught this class, was to fill a couple of gaps. One of the biggest gaps that I saw was the gap between, how we teach coding here on campus in your classes versus how coding actually is once you get out into a job or an internship or something like that. Those of you who've already had internships have maybe already noticed, right? There's kind of a big difference between, the coding that you do on campus versus the coding that actually out there for a company in the real world. And I kind of want to give people a little bit of a taste of that to get you used to that mindset. Maybe the biggest difference that I see is that in class on campus, we ask you to do an assignment or write some code. You submit that code and then you never think about it again, right? You never have to work on it again. You never have to touch it again after that. You ship it into the instructor, you get your grade back, and then that assignment is over. It's in the past. It's in your rearview mirror. That's not how real coding works, right? If you get hired as a programmer at a job or via an internship, you're going to be working on the same code base for months, years at a time, right? So you're not, yes, you'll be working on different parts of it, but it's actually going to be revisiting the same section of code over and over and over again, making improvements, fixing bugs, adding new stuff to that code, right? In pieces over time. So it's a lot different than kind of what you get in the academic environment where it's just, get through all the requirements, ship it, and then it's done. That's not really an accurate representation of how coding works in the real world. So that was one big gap that I really want to try and solve with this class. Give people the taste of working on a project over a longer period of time. We still only have 15 weeks, so I can't make you work on it same project for years, like you might do at a job, but I can still make you work on something for, longer than you might work on a project traditional complex. The other thing that I kind of am hoping to, the other kind of need that I'm hoping to serve with this class is that there's a lot of useful techniques and tools and things that we, don't always necessarily cover explicitly. You might catch some of them just kind of on the side as you work through upper level classes, or you might pick up some skills if you get an internship or something like that. You might get some of these skills, but things like the command line, things like, unit testing, they're all very important parts of actual professional development. Prior to this class, didn't really have a home, didn't really have a place where, that is where they would cover inexplicit. So I wanted to create this class, and this, is an important detail that I hope all of you understand. I want to create this class for new computer science students who are fresh out of the intro class, first years, maybe sophomores. Give them these skills early so that you have them when you take the upper level comp sci classes. You already have these tools in your back pocket, and hopefully will make those upper level comp sci classes easier, more coachable, right? A bit less intimidating than they would be if you didn't have those. So That's not to say that if you're a junior or a senior, which I know there probably are some juniors and seniors in this class, you're still welcome to take the class, but I do want to be clear that this class is really for you, right? Like there are definitely some skills that I would expect you already know, but you'll also get some stuff out of it. It won't be a total, rehash of stuff that you've already picked up, hopefully. I do hope to go into a lot of detail on these topics, so I do think it's still worthwhile if you're a junior or senior, but my real focus is for the novice programmers, like I said. 1301, the intro class is the only prerequisite for this course, and that's for a reason. Those are the students that I'm targeting. Students who literally just took intro last fall with me are the students that I most hope to see in this class, and the students that I think will get the most benefit. So, if that applies to you, great. If you're a junior or senior, you are very much still welcome here, but I hope you have some patience because I'm going to be talking to those more novice programmers and might be moving at a pace that is a little bit slower than what you yourself could potentially do if you're more advanced. Right. So what I want to do next is your typical syllabus day stuff. Go over what the structure of the course is going to be like, as well as a brief overview of the topics that we'll be covering in class. So the class is kind of split into two halves. The first half of the class, which lasts till right around spring break. Actually, spring break is kind of a nice natural breaking point, halfway point. It's going to be more of a lecture style class where I introduce a topic in class, give you some exercises to work on in class, and then there will be assignments. However, those assignments are going to be expected to also be done in class. And I'll talk a little bit more about that in just a moment. After spring break, we're going to switch into project. So I think there's only one in-class assignment after spring break. Most of them are before spring break. Because after spring break, you're going to be working in groups of 3 to 4 people on a project. And one of the big reasons why I like the project is because you're going to be working on the same project for the entire rest of the semester. So it ends up being a 6-week long project where you are working on the same thing. You're actually submitting the same project 3 times. So we're going to go through 3 different, what we call iterations on the same project. And every time you submit that project, you're going to get feedback on it, where the stuff that you do well, of course, so we have credit for doing that. The stuff that needs some work, I'm going to point that out to you and be like, hey, you can fix this with a math integration, right? That's pretty different than I think a lot of assignments that you do are structured like. Also, what I'm looking for on the project is a lot different than maybe what you're used to on these assignments as well. Whether the project works is part of the grade, but it's maybe only about a fifth, right? The other things that I'm interested in this class are, are you contributing to this project in a professional way? Meaning, are you keeping your repository clean and neat? Are you using proper professional, techniques for adding code to this project? Have you justified the additions properly, right? You're not just throwing any random thing in the project, but you've actually thought about the pieces that you want to add and are adding them in a clear, methodical way. So those are the things that I'm hoping to teach you in the first half of the class, and then kind of turn you loose from the project and apply them in the second. So let me go into some more of the grading kind of syllabusy stuff in more detail. These in-class assignments are actually already on the calendar. And the way that those are going to work, you're going to show up on those days and there will be an assignment. And I'll give you a brief introduction for that assignment. And then the rest of the class is going to be you working on it. And by you working on it, I mean you, the human being, right? One of the things that I'm concerned, one of the things that I'm concerned about is the use of AI, of course. That's something that all of us are interested in these days, but I think it's important for you, the human being, to show them what you are capable of. Or in other words, who has 2 thumbs and is sick of grading check homework? This guy, right? Like I don't want to grade stuff that is generated by ChatGPT. I want to grade stuff that is written by you. I want to see what you're capable of. Can ChatGPT do some of the stuff that I'm going to teach you in this class? Absolutely it can. And I'll actually be happy to talk about that more in the second half of the semester, right? I'm not going to ignore the fact that AI has become a part of our lives, and part of a professional development toolkit is AI, right? But AI has a multiplier effect, meaning that if you don't know anything, you're multiplying by 0, right? The AI is not going to help you, right? The more you actually know and understand about the topic you're asking AI to help you with, the more effective that use of AI is. So I think it's really important to build those skills first with yourself. And once you've done it a few times, the hard way, right? Sat there and worked through the errors and cranked out problems, then your use of AI will be much more effective. As you know, the AI is going to be able to do for you, know what the gaps AI answers are going to be, because there will still be gaps, things like that. So I think it's really important for you to get those hands-on skills and do things that way. So that's kind of the goal behind in-class assignments. And I want to make it very clear that your attendance on these in-class assignment days is mandatory. So it says right here on the syllabus for the in-class assignments that you have to be here on days that we have in-class assignments. You have to be here physically. I will be taking attendance on those days. There will be assignment sheets. So the way that it's going to work, once you get here, I'll give a short intro about the assignment. You'll have the rest of the class. Shit. Unlike what you may have done in other classes, I actually very much do intend to go back once you have submitted the in-class assignment at the end of class and grade it. So I will actually look at it and grade your work. I'm not going to be super nitpicky with it though, right? I'm going to put things in 3 buckets, which is excellent, satisfactory, or poor, based on how well you've done, meaning that you don't have to check every single box to get 100 on these in-class assignments. If you get 90% of the boxes checked, then that's an excellent grade. If you get around 75% of the boxes checked, that's a satisfactory grade. And then anything less than that, we're looking at, poor grade territory. So this is not an effort-based assignment like it is in the intro class, for example, where you get credit just showing up and working on the studios. I am going to go back and not just grade the assignments, but also give you feedback on the assignments that you submit in this class. The hope is to, help you build those skills, and I think getting feedback is an important part of that. So I personally, me, not the TAs, but me, will be looking at all these assignments and grading after the fact, providing feedback after the fact. AI on these in-class assignments is strictly prohibited. So if I see anybody using ChatGPT on in-class assignment days, I'm going to tell you straight up, you're not going to credit for this one. But also, along those lines, I understand people get sick, especially this time of year, have other conflicts. So I will drop one of the in-class assignments out of 5. Whatever the lowest one is at the end of the semester, I'll go ahead and drop it. So if you get sick or something like that, you don't need to freak out too much. I also understand that sometimes you might have to miss more than one. That's definitely a come talk to me situation, right? So, if you miss one, no harm, no foul. If you have to miss more than one for legitimate reasons, come talk. That's not an instant deal breaker, but it's definitely a come sit down with me, come have a chat. Let's see what we can do about that kind of situation. So as far as the project goes, this is like I said, far in the future. We probably won't even talk about the project much until the week before spring break. But you'll be broken up into teams of 3 to 4, like I said, and there'll be 3 iterations. And after each of those iterations, actually, you will be helping me grade the project. So another big part of this class is the peer review process, which is another thing that we don't actually get a lot of experience with. And it's getting a little bit better. I think more and more classes are starting to incorporate peer review aspects. But in the the professional coding world, right? It's not one person writes the code and then shits it out the door. It's one person writes the code, tells their team what they've done, and then that team looks at the code and says, "Oh, hey, this looks good, but you missed this thing right here," or "I think there might be a bug right here." So that peer review it is a skill that needs to be developed. So once we get to the project, we'll actually be assigned to review someone else's project, which I think is another important aspect of the class. I will also, of course, be reviewing all the projects, but you are going to help me, and that will be taken into account as part of your project grade. So all of this I will go over in a whole lot more detail once we get to project time. But that peer review aspect is, I think, very, very, very important. It's a big part of this class. So I just want to make sure you got a heads up on that part that's coming. What else do I need to talk about in regards to syllabus day stuff? The whole calendar is actually mapped out. So if you are curious, when something's happening on a particular day, go ahead and click that calendar tab on Canvas and you can actually see I've already mapped out every single thing for the semester. There are two sections of this class. So there's one at 1 o'clock. So I'll be doing this for a second time after lunch today. If you are, unable to attend this time slot that you're registered for, I'm not necessarily opposed to you occasionally coming to the second class, but they're both pretty full, so I don't have tons of room for people to mix and match sections, and I certainly would appreciate a heads up if that's something you intend to do. Like I said, once or twice, probably not going to complain about it too much, but in general, I want you to come to this one. Please don't, unofficially change your section to 1 o'clock class without leaving your schedule forward. But you still have time to do if the 1 o'clock section work better schedule. What else? What else do I need to talk about? Oh yeah, office hours and TAs. So we do have two TAs for this class. You'll actually see them here on the in-class assignment days. They're going to be coming on those days to help me out. They're also going to be building office hours behind my office hours. I can't remember if I posted them yet or not. If I didn't, I will try to remember to do that. Okay. No, I did. Yeah. My office hours are by appointment. So if you ever want to talk to me, there's a link on Canvas. You just click that link, sign up for a time slot. If none of the times on there, I will definitely make time for you too. That's I want to all to feel like you have access to me and you come talk to me and have meetings. So the meeting times that I have publicly available don't work for you. I will figure something else out. I will make sure to find or we can chat if that's something that you ask. I don't think there's any other syllabus stuff I need to cover. I think I've actually covered most of it. Does anybody have any questions about structure of the course, expectation of the course, assignments, things like that? Yeah. Of course, I'm on it. What will it look like? So you're all actually going to be working on the same project. I think that's another maybe important piece that I didn't mention. I haven't decided the projects. I'm going to tell you what you're working on, right? I'm going to tell you what the entire class is working on. Last year it was a banking application, so simple, log in, make deposits, withdrawals, things like that. It's not going to be super exciting, to be honest with you. But hey, guess what? If you get a job as a programmer, right, it's probably going to be on something that's not exciting necessarily. There's a lot of banking apps in the world. There's a lot of, resource management tools in the world, right? There's a lot of just general functional stuff that is not going to be as flashy as video games or things like that, which, I'm a big fan, but this isn't really the class for that kind of stuff. Yeah. I haven't decided on what the actual project is going to be. I will make sure to let you know. Yeah, awesome. And you will have some input too. I think that's important to say. For the first part of the project, I'm going to tell you what to do, but as we move on, it'll become more open-ended. So it'll become you get to decide what to add on to this project, as opposed to me telling you what. Yeah. Any other questions? Yes. I'm sorry. They are individual. Yes, they are meant to be worked on by yourself. And I guess I should make it clear that while AI is strictly forbidden on the in-class assignments, I am not opposed to using the internet on in-class assignments, right? So if you want to look up a piece of information, that's good programming, right? Being able to look up how to use a particular library or how to use a particular command, I am all in favor for that. In fact, some of the assignments will require you online where to complete the assignments, just not asking AI to do it 4 inches. The red line for sure. But it is meant to be done individually. Some of them are going to be personal. Some of them are going to ask for your own personal opinions, your own personal thoughts. Reflection, I think, is an important part of learning. So I've been trying to incorporate more opportunities for reflection in all of my classes. There will be opportunities for you to reflect on what you learned in this class, but also I hope to take these skills and think back on what you've done in past classes and reflect on how those skills may have helped you in those past experiences. Well, and maybe also in the future, how do these apply to your current interests, what you want to do? So that's kind of some of the assignments will be technical. They're going to ask you to do a technical thing, write a script, something like that. Some of them will also be personal in nature. Yeah, great question. Any other questions that I can address before we move on to the next item on my agenda? Okay, awesome. So the next thing I wanted to do is just give you a brief overview of the topics that we're going to be covering in this class for the first. So the topics, again, to remind you, the class is kind of in 2 halves. I'm going to cover 5 topics, 5 major categories of topics in the first half of the class, and there are 5 in-class assignments. So that well. And then the criteria that you're going to be graded on in the project, 5 different criteria. So the things that I'm trying to teach you about in the first half of the class are exactly the kinds of things that you can be graded on the project, right? And so the first thing that I'm going to teach you, the first thing that we're going to get into on our agenda, we're actually going to start this on Thursday, is an introduction to the command line. So I think it's an essential tool. We're going to be using the bash command line for this class. Yeah, I know some of you may already have an experience on the, which is great. I still learn tips and tricks, even if you've already used the command line before. I'm expecting some of you have never touched the command line before in your life. So that's really, all right, we're going to start with the very, 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 very basics on Thursday. That is our goal. But we're going to work our way up to some more advanced command line kinds of techniques. After we get through the command line section, we're going to move into talking about scripting. So actually writing scripts to perform tasks for us. It's related to the command line, right? But the idea behind scripting is we can now automate our command instead of having to type commands in. We can actually, if I've been using the word script, it's exactly a program. It's more of a series of commands rather than a series of coding statements, but you'll be doing some scripting, and then we're going to hop into Git. So I would say most, not all of your classes, I know for the intro class, for example, we teach students how to commit and push. We teach students how to clone a repository. And that's about it. And for most classes, that's most of what you need, but there's so much more. Git is capable of doing lots of different things, and there are actually some very important parts of Git for professional development, right, that we're going to talk about in this class, specifically branching. It's a big one that we're going to be talking about in this class. So how do we use branching, which is an extremely important concept to understand if you're ever working on a team. If you're just working on stuff by yourself, branches are kind of overkill. But if you're ever working on a professional development team, branches are essential. You're going to be expected to use proper branching strategies as part of any professional development job. So that's a big thing we're going to be talking about. But we're not just going to be talking about branching. We'll also talk about some of the logistics behind how it works, how to check logs, how to make commits properly, and we're going to be doing it on the command line. So not through VS Code or through your IDE, but how do we actually run the Git commands on the command line is a big part of that. Well, once we get through the Git section, we're going to hop into unit testing, test-driven development. This is another thing that I think classes kind of train students a little bit backwards when it comes to this. And I'm guilty of this as well. In 131, in 1301, for example, the intro class, For some of the assignments, we give students unit tests, and then the goal is to pass the unit tests. Well, where did the unit tests come from, right? Like, if I'm working on a project, the unit tests aren't just going to magically appear for me to figure out how to pass them. Somebody has to write those tests, and that somebody is you all, right? There's not going to be a professor writing unit tests for you. That's something that only happens here while you're on campus. So how do we write unit tests? What makes a good unit test? The idea behind test-driven development says we should write the unit tests first before we write any code, which is that is an uncomfortable thing for a lot of students, especially when they first learn it. But I think it's a powerful, powerful technique. Even if you maybe don't end up doing true test-driven development, I think it's still good to be aware of it. And it's certainly good to know what makes a good unit test and what does make a good unit test. And then once we get through the unit test section, we have a big section on code quality. So another, kind of pitfall of the way we teach coding is we care about whether it works or not. And as I'm sure some of you are aware of, and I'm certainly guilty of this as well, the stuff that I turn in might, check boxes, do what it's supposed to do, but it's kind of, held together by duct tape. It's fit, like it's not the prettiest code in the world. I would be embarrassed to show it to someone, because it's got methods, or maybe in the extreme case, maybe it's just all in one big method, right? So that's not good programming. That's not quality code. How do we write code that is not just functional, but also high quality? Code that is not going to fall apart if the wind blows on it the wrong way, right? That is a big, big part of this class. So we're going to spend a lot of time on code quality. How do we know whether code is good or not? And then how do we actually write code that is good? Although actually, in practice, what it ends up being is, well, let's write the rickety looking code and then go back and fix it later. We don't always spit out perfect looking code the first time. It's more like, well, let's write the code that works and then make sure clean up after ourselves afterwards. I relate it a lot to cooking. I do all the cooking at home. I like to bake, I like to cook. You make a big mess, but at the end you clean it up. You make it look nice, right? So you're still allowed to make the mess. You're still allowed to write the sloppy code. You just have to remember to come back, back to yourself. Done. You're going to be getting paid to write code, right? If you're getting paid to write code, that code better not look like slop. Boss isn't like that. Your coworkers aren't going to like that. And you yourself aren't going to like that, because someday you're going to have to come back and work on that code again. And if it looks like slop, you're going to be like, oh my gosh, what do I do? This looks terrible. How am I supposed to fix this? How am I supposed to update this? If it looks nice, that's going to be much easier for you to revisit that code in the future and add things, fix things, do whatever it needs. And then sort of I know I said 5 topics, but there's sort of a 6-ish topic, which is project management. So how do we actually work with that? That'll become, so we don't do much on that in the first half, since everything is mostly individual in the first half, but once we get to the second half of the class, project management. So how do I make sure that my team knows what I'm working on? How do I make sure that what I'm working on does what the team members are working on? How do I make sure that my team members give me appropriate feedback once I'm done working on whatever it is that I'm working on? So that's another topic we'll be covering in this class towards the back half of the semester. And that's it. There'll be other little things along the way, but those are the main categories of things that I'm hoping to discuss and work with you on in this class this semester. All right. I've got a couple of other things on my agenda for today, but I just want to pause again real quick. If anybody has any questions about anything that I have said or discussed so far. And if nobody has any questions for me, then I actually have a question. I actually have a couple of questions for you. I'm going to ask you a question here in just a moment. I'd like for you to I'm going to give you, I don't know, 10-ish minutes to talk about it with your neighbors. Also, there's a team project coming up, so you can get to know some of your neighbors and start thinking about. You don't have to form teams today, but you will eventually. So it's a good idea for you to talk to each other, get to know each other a little bit, so that when teams come along, you'll actually have some people in mind of who you want to work with. I want to ask you a couple of questions, kind of set the stage, kind of get your brains thinking about what we care about in this class. So the first question that I have for you, I'm going to write it up here on the screen and then let you chat about it for 10 minutes. What makes a good program? If you are asked to work on a body of code, right? What do you think that code should look like? Versus, a program that would care about you or make you angry at work. So what are the qualities of a good program? Take a moment and think about this. Talk to your neighbors. And after about 10 minutes or so, I'm going to ask for you to tell me some names. I'll be around to introduce myself as well.
I would say on the data side, it's like and I don't think like all the things that like that. And you don't have to do I'm trying to no, not really always proud of it. I started trying to get not problem with the and it's really interesting. If I go back, you have to invite it, and then you'll look at it. Yeah. It's like, I mean, you want people, yeah, please. My program, not really. And I dropped this. It's like every gym one day I told you I had something like my God is so it's not yeah. I took data mining and hacking on it would be pretty so let's say you're on the next well, where the user starts from. So, I'm gonna go with like where I'm studying and like no one's like on Mondays I'm today I'm only like break. So I'm going to without going my brain I'm even trying to so I'm not like when I see that scene I was like you can defend the like skipping and just I might read okay, I'm not I'm read this thing. Also, what? Wonder like really good everything for that you have and I think maybe for like because the more money the volume it's like of the gospel. It's like the band like big creating small like gospel that's and I know it's like a deal on it's like it's not that's great. I'm more like make a party. You like Chicago, I you every I like to like 5 I just registered the class right now. Okay. So I'm doing the class like do I miss people?
I went through all the syllabus and Canvas stuff mostly. They're answering this question right now. We're going to talk about it in just a couple minutes. You're welcome. Come on in. Have a seat. I also recorded on YouTube, so you can check it out later.
Okay, yeah.
Yeah.
I don't like I miss anything you want.
I mean,
Just
just
the syllabus.
syllabus stuff mostly. Yeah.
Okay, is there any assignment or
Not yet. Not yet.
like so but not just lecture.
Yep. Yep.
I'm gonna cover and I'm playing dinges. No longer actually. I'm gonna tell my ears. I'm staying over. And each and then you have like then I got really yeah hot dogs and the party and why don't you go
Hey, let's see this. Next. Right, which I think is a good place to start. I think we all kind of at least know some of, in the maybe in the back of our mind, or maybe in the front of our minds, right? That okay, this code is kind of garbage, but let's think about the opposite of that. It's easy to maybe identify what is bad. Right? Say How do we define what a good program is? Can somebody help me out here? Give me an attribute, a quality of a good program, a good basic code. Yeah. Comments. All right. And this is a tricky one, maybe somewhat of a controversial one. I think over commenting is definitely a thing, right? Where if you're writing a comment on every single line, that is no good. That is overkill. So knowing when to use comments, when not to use comments, that means we'll talk about that. That's one of the things on our to-do list. Yeah, what else? What's something that can help us from having to write a whole bunch of comments? If we do a couple of other things properly, maybe we don't need as many comments. Anybody think about that? Yeah. There we go. Naming things. Uh, classic 1301 assignments. I think it's almost rite of passage for students when they start programming. It's hilarious to call all of my variables, hoop and fart, and my friend sucks or whatever. Like it's hilarious, right? It's funny, but that's not a good variable name. It's not descriptive. It's not telling you what's going on. Similarly, maybe a more realistic example, calling everything X, Y, Z, like, yes, it's short, it's less typing. Maybe I'm in a hurry. Unless I'm talking about like X, Y coordinates, though, that's probably not the best choice for a variable name. So naming, I think, is very, very. What else? What else is good? Yeah. Keeping it simple. Yeah, I think this kind of goes with something that I mentioned earlier, where it's very tempting sometimes to put everything into a big giant method, right? But keeping things simple. So especially methods I'm going to put here is huge. Instead of having giant methods that do a whole bunch of stuff, I want to have lots of tiny methods. One thing with very that is a very big goal of ours in this class. What else? What else? Think about a chunk of code that you'll have to come back and maybe change later, right? Code that you're going to be working on for a long time. Or I guess what I'm trying to get at is concepts like updatability. How easy is it to update code in the future? That's something we care about. Kind of related to a similar concept, maybe another word for the same thing, I don't know, but maintainability. They're slightly different. Maintainability, if I have, for example, a date that's hard coded, here I have to go back and change that date. That's not very easy. That's not easy code to maintain, right? It's not a maintainable. I shouldn't have to go back and fiddle. If you're paying attention to what I just said now, I actually maybe said another thing of another quality of code that I expect to see. Dealing with hard coding things. What's that called when I hard code things into? You have a name for that. Hard coding stuff. Like I have 9.1 just for the time I'm talking about graph. What's that? Yeah. Magic numbers. There we go. Magic numbers. So well-defined, uh, well-defined constants. No magic numbers. Let's think a little bit on a broader scale now, right? I could write a method. So earlier I mentioned I want to write a method that does one thing, does it very well. But we can take that to an extreme too, right? So if I write a method that is very narrow in its focus, maybe it updates one person, five. But then, I have another person who I also need to update. I'm going to write another method for that. And then for the next person, I'm going to write another method for that person. The solution to that problem would be, oh, hey, with a method, we want to create a parameter. And then instead of having, one method per person, I can just feed in the name of that person as a parameter, and that method will work for whatever parameter I written in there. What's that concept? What do we call that? Does anybody know what that idea is referring to? Say it starts with an R. Reusability. Being able to use the same piece of code over and over again, instead of having to write the same piece of code over and over. If you ever find yourself copy and pasting a chunk of code, that's an instant red flag, right? Like, oh my gosh, don't do that. Because then if there's a bug in that code, you just copy that bug. You now have that bug in multiple places. We want to be able to reuse the same code over and over and over again. What's another technique? I described using method parameters for reusability. It's another coding concept that helps with this reusability idea. Starts with an I. Nobody? We cover it in intro class on Rule 8. Towards the end of the semester. Especially if I want to reuse code across multiple classes. How do I do that? We may need to brush up on this one then. Inheritance. Inheritance is what I'm referring to there. The idea of writing code in one class and then reusing that code across multiple classes. That's what inheritance provides to us. I would say that you don't need to force yourself to use inheritance, but what I'm really getting at here is good object-oriented design. So just like with the methods, right? Putting everything into one method, not good. Putting everything into one class, also not. You want to have lots and lots and lots of different classes, lots of objects, lots of generic kinds of objects over, over again. So I think these are some of the main concepts that I'm hoping to get you to think about as we write code in this class. These are the kind of things you're going to be great about, right? So as I mentioned before, especially when it comes to projects, whether it works is just scratch. Great. I'm going to be looking at stuff like this. Do you have giant methods? Those can go. Do you have everything in one class? Oh, then you need to break it up. Smaller class. Those are the kind of things you're going to make, especially when we get. These are the kind of things that I want to train you on because this is what separates a novice programmer from more advanced. Which is a good segue into the second question that I have for you. So, not just, let me make a new file for this one. I'm going to do the same thing. I'm going to give you a question to talk about with your peers and give you a good 10-ish minutes to discuss, and then we'll regroup, talk about the answers. Instead of what makes a good program, this time I want you to think about what makes a good programmer. So now we're thinking about the human writing the code. What skills on the team? What are the skills that you would hope to be effective projects, or maybe even as a hire, right? I hire a new programmer team. What are the skills that I would hope those programs that would be good contributors to the team? Being able to write good code, and that's too generic. That's not. Think about, the personal skills that you would think a programmer would need to be successful as a professional programmer. Go ahead and talk to your neighbors again. I'm going to give you another 10-ish minutes, and then we'll talk about the answer.
My brother's the soccer and like he has to like sign with the building for like the website goes to the mom and then I'll be like pay it and he has to like go with it. So I just think like being able to like work on the fly, like critical thinking. And sometimes it's just like a little band aid. And like if they're police stuff. It's not just about knowing what you feel like life on the top and like that's feedback. And only needs to know what you're doing. I mean, I would like the ability to like use genius spring like I could grab things flexible your way doesn't have to be all inside that it's now six hours for dealing with craft or not we have we have one that starts the I would make the prayer. Racing. What would you go? Not very good. Thank you. Yeah. Like that's what this team like look at this thing is for me. And so I look at I don't even keep you know I love that first thought but like your brother was signed it's been doing one thing. I think you should like so you know you're thinking about I stuck in my list. Oh, seems like the and this is
Well, it's really
I started the lady to track the and that was the my body so I get I guess they like the music cloud so I was like right. I was just it's like straight frosted. Oh. We're not talking about my job and well, I can't have one. Oh. I was like, being kind of, I was like, I saw you thought that I'm down there for like I don't know myself. And I've been there like Spain, you know. June. Yeah, I weather's bad. I mean, it's just all. Oh, yeah, I don't know. I'm a little like sweet. That's why. Yeah. My feet. I like the Scottish and a little bit. All for
Story that'll be the next product. A lot of us, not all of us, are going along the way. Hopefully, it doesn't happen in this class, although it could. There have been some that did not always get along super well in this class in the past, and honestly, that will happen after you graduate and get a job in the programmer as well, right? Like humans are humans, aren't going to be on their way. That's uh, fortunately fact of life. But let's not focus on the negatives. Positive aspects. What are the kinds of things that you hope your team members or also yourself will the skills that will have that will make you a good programmer? Who can help me out? Yeah. Documentation. Oh, okay. I think yeah. I like the reading part especially. The writing part is usually people's least favorite thing to have to do. It's kind of like complete to get me right down. So important. Especially when you think about the opposite side of reading. As part of our job as programmers, we read that all the time. That's how we know how to use certain sets, how to use certain libraries, incorporate certain pieces of our code, or just how to get things to work. So that documentation is very important. What are some other qualities that you would hope a good programmer would have? Yes.
And with writing application, but being able to explain your code to someone else, like
Yeah. So I would, communication, right? Communication is huge. We do not program by ourselves. I mean, yes, we do program by ourselves, but for me, most of the time, that's personal projects that I'm working on at home. Or even if I do code something by myself, eventually I'm going to have to talk to somebody about what I did. Because for large scale applications, they're not done by one person, they're by many people. We have to be able to communicate with those people, not just what we're working on, but what they're working on. And I think, kind of along the same lines, I think this is another important skill: ability to give and receive criticism, right? Because you're not perfect. I hate to break it to you. Neither am I. I'm not always going to write things when it would be written. Sometimes I'm going to make mistakes. Sometimes I'm going to do it wrong. Sometimes I'm going to misunderstand what I'm supposed to do. So way off, a totally different direction. So, if somebody called you on that and says, hey, like hopefully they're not a jerk, right? If somebody calls you on it and says, hey, I don't think this works, or I don't think you understood here, it's important to be able to take that criticism and not take it personally. Like, yes, okay, yeah, I screwed up. Sorry about that. Fix it for you. Let me figure out how to do that properly and then fix it. Because people are going to be looking at your code and they're going to be providing feedback on it. Some of that feedback is going to be, hey, this doesn't work. There's a bug here, or I don't understand what's going on. You have to be able to take that kind of criticism. That is just a part of being a programmer and getting better at the program. Being able to take that kind of criticism. Yes. Yeah, so asking questions kind of goes along the lines of being a lifelong learner. It is impossible to know everything that you could know about coding, yes, or any of the topics we're going to talk. I don't know everything that there is to know about Bash or Git or clean code. I'm still, I've been doing this for 20 years, right? So it's just not possible. Understanding that that's not possible, accepting that fact, right? Not trying to pretend like you know everything, not trying to pretend like you're smarter than everybody else in the room. Uh, you've probably met people like that before, right? That's not conducive to good teamwork. So accepting your own limitation, knowing what your own limitations are, but being willing and able to go out and learn, ask questions, and fill in those gaps when you need to. It's such a crucial part of being a programmer. Most jobs that you get hired for might ask you to do skills or write in a language that you've never seen or touched before in your life. That's not nearly as important as your willingness to go out and learn about it and do those things. So I think that's hugely important. What else? Any other qualities I think would be essential? I can think of one that I think would be essential. Problem solving, kind of related to all of the others, right? But this understanding that mistakes are going to happen, we have to get in there. So being good at problem solving, being good at figuring out what problems are, and then being willing to look up the information necessary to fix that. So I think that personally using the debugger is an important skill. These lines, one that is very underrated by most. Spend some time talking about debugger in this class. I'm a huge fan of debugger because 1301 with me, you probably already know that. So I'm going to be showing you how to use a debugger all over the place in this class. And that's because it's extremely important tool for being able to figure out how to solve problems, figure out where the problems are, solve them, because there's always no, just like no human is immune from making mistakes, no piece of code is ever perfect. No piece of code is ever without mistakes, without bugs. So being able to figure out what those are and solve them is a crucial skill for any programmer's plan. Anything else that you all discussed that you came up with your classmates about skills for the program? There are some that I think are, so sometimes I get answers like honest. Well, yeah, I hope everybody's honest, right? So that's not unique programming. Of course, we don't want to be stuck with somebody who's a total jerk and is going to lie to us about everything. But I think these are skills that are specifically for programmers so right? Especially just the side of understanding that we're all going to make mistakes. Nothing's going to be perfect. We have to be willing to accept those mistakes and recover and be willing to learn about, proceed on. That I think is another kind of vibe that is that is going to be going through this entire class. This idea that we're always in a perpetual process of learning and making mistakes is part of that process. So cool. Thank you so much for participating in this little thought exercise. I might refer back to this actually throughout the semester because these are the ideas, these are the skills, these are the core concepts that I'm really hoping to infuse in all of you as we go along this semester. We're going to wrap things up in just a minute, but before you all take off, I just want to point out one thing. Unfortunately, I'm getting a little bit ahead of myself. On Thursday, we're going to be covering the and I want you all to bring your computers and be ready to write and I'll be showing you. I hate slides. You will not see a single slide in this class. It's going to be all me working on my computer, running stuff on the command line, writing code, and stuff from me. And I want you all to do the same. I'm going to give you exercises to work on in class on your computers, right? To get practice. So I want you all to come back on Thursday, ready to do some work on the command line. Now here's the bad news for some of you. Mac users, you already have a nice command line already on your machine, right out of the box. Windows users, you also have a command line, so you need to install a better one. I'm a Windows, so I actually do not at all. But this is one thing that Macs do well, that Windows machines do not. I'm willing to admit that. We are going to be using a Linux-based command line. So Mac users, you're all set to go. You don't have anything to worry about. Windows users, however, I'm asking you to install a different command line on your computer called Linux Subsystem for Windows. I actually just did this myself. My old laptop. So literally just yesterday, I ran through this process myself on a brand new computer. So it was very fresh in my mind. The Windows machine, we still have, 10, 15 minutes left. It won't take you that long to do. So I would encourage you to maybe even just stick around for a few minutes, get this taken care of, so you're all set to go for Thursday. That way, if you run into any problems, I'm here to help you out. If you want to do it on your own time, that's fine too. I can maybe stay, just letting you know that that's something that I'm hoping you'll have done for Thursday, so that when you get here on Thursday, we're ready to start. Otherwise, that's all I have for you today. So, only questions about. Get started.
Sorry, God. Yeah, yeah. All left.
You do have to. So, you end up having to come up with a modification. Yeah. Yeah, see you on Thursday.